Hey everyone, this is Baylor, and in this video we're going to build a framework around the Hangfire job library. So if you're not familiar with Hangfire, it's hangfire.io, and basically what it is it's a way to queue background jobs or recurring jobs with basically just a C# expression. Now, the reason this is very cool is because it gives you a ton of power, because it will, in the background, figure out where your object type is and the method you're calling and its arguments, and it'll just run that in the background without you having to write a lot of service architecture. Downside is that because you have a massive amount of flexibility here, it's very easy to kind of get unwieldy, and you could pass anything you want here, and so we want to find a way to avoid that. So what I've done here is I've created a new project. The source is on GitHub. Feel free to pull it down and follow along. Everything here is running with Docker and Docker Compose, which allows us to very quickly and easily start this up and have everything running for us. Real quick, we'll just look at the Docker Compose YAML file. You can see we have 3 services running. We're using Redis as our backend because Redis is very good at running background jobs because everything is stored in memory. And then we have our front end application, which is our MVC. We also have worker 1. And this also runs to a Docker file as well. And let's correlate to these 2 projects here. So to start the project, the first thing we'll run is Docker Compose build, and we'll run this in the root of our directory where we have our Docker Compose YAML file. This will go ahead and run through both Docker files for both the front-end MVC application and our worker 1. It'll build these images so that when we run our Docker Compose up-d, it will use those images and it'll create all the services running, and you can check on the status of these by running Docker Compose ps. And you can see everything here is running. And if you want to see the logs for a particular service, you can say Docker Compose logs, and here we'll look at our front end. And so this indicates the server hasn't started. This indicates the server has started. As you can see, it's now listening on port 80. And if you look at the Docker Compose, you can see that we are forwarding port 5000. And so that's what allows us to be at port 5000 here, and we still see the application. And if you need to run this first to make sure everything works, you should be able to click this view dashboard link and get the Hangfire dashboard. And this services count is wrong, but it's just because it hasn't refreshed with the Redis database yet. So we're going to look at implementing our Hangfire framework with both of the scheduled repeating task or recurring task, and also a background job that takes a long time to complete. The way these are both implemented is they're following a common MVC structure, as I've created a skeleton that has our MVC project that references our common, our services, and our core. I've added a dependency graph to this project so that you can see how this works. At the very bottom, we have our core. This is basically going to be interfaces and objects that are very, very light. Those interfaces will be implemented by our services library, which will then be delegated through common so that things that are required both in front end and in worker can all be shared. And this should follow a very similar pattern in any MVC project that you look at today. Now, to show you how that common project is interacting with our front end and work applications, we'll take a look at the startup class in our front end project, where we define our configure services. We've added this extension method for add Hangfire framework services. And so what this extension method does is we basically have a place to define that we want to add anything that is common and shared between our front end and worker project. And so in this case, the only thing we have is a task service. And this is the task service is used to schedule our long task and our recurring task. So to see how this task service is used, we can hop into our task controller. And you can see we have 2 actions here. One where we have a long action where we say we're a task service, run our long running task. And we have a repeating where we say task service repeating task. And if we hop into this iTask service, you can see all we're doing here is very simply just saying that for our long running task, we want to write to the console that we started. We want to start a stopwatch, sleep for 2 seconds, and then show the time elapsed. And then the repeating task isn't possible right now because we don't have Hangfire implemented, but this is where we would trigger and say that we want to start a repeating task. So the first thing that we're going to do is we're going to create a new interface. And so we'll just say we want to add an interface, and we're going to call this iJob runner. And we're not going to implement what this definition will be first. What we'll start with is another interface that will be our iJob options. And the goal will be that these options, we can define here something that needs to be shared across the entire application. So that if we want to, for instance, say every job requires a user ID, that we can put that here, and then we know that every job is going to have a user ID. We don't need this, so we'll take this out, but that's an example, and I think it's worth putting here so that you can define these later as you need them. The next thing we'll define here is another interface, and this is going to be our job, and this is going to take in a type of tjob options, and we'll say where our tjob options is a type of ijob options. And when we define an ijob, then this is going to have a void method called perform, and this will take in an type of our tjob options, and we'll just say these are job options. And then so the way this will work is whenever we want to have a job that runs, we'll know that it'll be a type of ijob, and we know that we'll always get back an instance of ijob options, and then I'll have whatever we defined at a minimum here. And so what we'll do here is to schedule these jobs, we'll go into our iJob runner, and we're going to define a method. It'll be void. It'll be called queue. It'll take a type of tjob and a type of tjob options. And here what we'll define is an action, and this action will take in an instance of tjob options, and we'll call this configure job. And then here we'll define that where our tjob options is a type of iJob options, and we'll also specify that where tjob is a type of iJob that takes in the tjob options. And so this method here, what our goal here with this method is so that we can explicitly state that we're going to queue a type of tjob, and we're going to force that we're going to have an instance of tjob options here. This will get passed in as a callback so that we can configure this very similarly to how MVC work when you see things like add Hangfire with options as a callback. And then we're specifying that these have to coincide with however we define our job. And so let's kind of play with this. We've not implemented these interfaces, but we can play with it and see how this will look. And so we'll do that inside of our services library, and we're going to define a new directory here called jobs, and we're going to define our first job as a class, and we'll call this our long running job. And so when we define this, we'll just say that this has a public class for our long running job options. This will be a type of our iJob options. We don't have to implement anything here because we don't have any options, but we will have these here for us. And we'll say our long running job is going to be a type of iJob, and the options type here will be long running job options. And so now this is going to ask us to define our perform method, and here we'll take in an instance of long running job options, and we'll call these options here. And so with this in place, now we can play with this and actually have something to work with. And so we'll hop into our task service, and where we were calling this whole method here, we're going to move all of this code over into this job perform. And this is because our task service is going to be used to queue a job, but it's up to the job itself to actually run by the worker and do this long task, and that'll allow us to have a very fast application. And so for this to move this in our task service, we'll now specify that we need to have a instance of our iJob runner, and then we'll define a new constructor here for our task service. It takes an instance of iJob runner, and here we'll say job runner is equal to job runner. And now when we queue this task, we're going to write out to the console that we're queuing our long running task, and then here we'll tell our job runner that we want to queue, and we're going to queue a type of our long running job. We specify the options here are long running job options, and then we get to configure these options here. And so we'll say our options. Now we don't have any options. Maybe we will just go in here, and instead of hard coding this from seconds says 2, we'll say that I will have an int for our task time, and it'll by default equal 2. And so now what we'll be able to do is when we queue a job, we can say that our task time has to be, and we'll say for now, there'll be a 10-second time. And so this will be the syntax for us to queue our jobs. And by doing it this way, we're abstracting away our job runner so that right now we're using Hangfire, but by using these interfaces and extracting it out, we're not required. We could switch to EasyNet Queue. We could switch to any type of queuing service that we want. And the only thing that I would like to do now, because we're kind of defining this structure here, I'm not a huge fan of having to call queue with the job and the job options. And so what I'd like to do is go back to our running job, and I'm going to define a extension class. So our long running job extensions. And here what we'll do is we'll define a static void method called queue long running job. And this will be an extension to our iJob runner. And here we'll just pass in our action for our long running job options, configure job. And what this will do is we'll just copy and paste this. We're going to move this code over here. And now we can just say our job runner dot queue long running job, and our options here will be, we want to have our task time equal 10. And I'll change this. So instead of hard coding these options, we'll just pass in our configure job. And so now, as you can see, when we hop over to our service, we've abstracted how we actually invoke job runner to just having a actually semantic job runner, queue the long running job. Our options are going to tell it to have a task time of 10 seconds. And if we look over our long running job, we have what our job is, what it does inside of here. And then finally, we have our static class for our job extension, where we say our job runner now defines this queue long running job. And this long syntax that defines all these different types can be taken away to just being used by this one method. So the next thing that we need to do is we've defined this interface for our iJobRunner, but we haven't actually implemented it. So that if we tried to use this, it would break. And so what we'll do is we'll hop into our common. And in this common, we're going to add a dependency here to hangfire.core. And so hangfire.core is the lighter version. It doesn't include the dashboard that you see in the MVC project. It has just what we need so that we can say that inside of our front end and our worker that we're going to have Hangfire available to us. And now we can hop into this common project. We're going to add a new class called JobRunner. And this JobRunner is going to inherit from our iJobRunner. And we're going to go ahead and implement the missing members here for our queue. Now for this job runner, what we're going to do, because we're using dependency injection, we're going to need an instance of the iBackground job client, which we'll call background job client. And we'll add this to a constructor for our job runner, where we take in that background job client, and we'll just assign the background job client so we have the instance. And what we're going to do inside of this queue method here, inside of this queue method, first thing we're going to do is create an instance of our tjob options. So we'll say job options is equal to activator.create instance of our tjob options. And then what we can do is call our configure job with these job options. And so what this is doing here is we take this type, we create an instance of it, we call the callback or invoke the callback that the user has defined how to configure these options. And then what we want to do is we want to just pass this to our background job client and say that we want to enqueue the type of our tjob. And we're going to call this method on our tjob. So we'll say job.perform, and then we're going to pass in our job options here. And so this is all that's needed so that we can take in a type of, or when we queue this job, we're just going to create an instance of the tjob options, and then we're going to enqueue for our instance of tjob the perform job options. Now by using this syntax, what's very cool is that anything we register as a dependency injection will be given available to us. And so the way that works is if we hop into our worker for our program, you can see we create a new service collection. We're adding our Hangfire framework services. And then we're going to global configuration, which is part of Hangfire. And we're registering an activator to use a custom worker activator that simply says when we need to activate a type, which is for our IOC, that we're going to go back to our service provider and use whatever we've already defined from above. And what's very cool is that because we have this configure IOC, everything we define here will be available to our front-end MVC application and our worker and any job that gets registered. So in this case, in our job runner, we say enqueue tjob. And if you remember when we defined this, we're queuing a long running job. And so that means that it would actually queue an instance of this class. And if we, for instance, said that this has to have an instance of our iTask service, then because we've registered this, our Hangfire instance would actually create a new instance of this class correctly. So the last thing we need to do is just go back to our configure IOC, and we need to register a few things here. First, we need to register we have a transient for our iBackground job client, which is an instance of background job client. And then also we need to register our job worker. So I add another transient for our iJob runner, and this will be an instance of our job runner. And so now what we can do is we're ready to actually run this and have our jobs get queued through our Hangfire worker. And so what we need to do is hop into our project and say docker compose build. And this will go through and see that we've changed our projects. It'll restore packages for us, and it'll compile them for us. And then once that completes, we'll just say docker compose up-d. And this is going to say that we've already have Redis up to date. So we're just going to recreate our worker and front-end application, and it'll boot those for us. And so now that that is finished and we have our servers running, we can check that with docker compose ps. And you can see they're both up. And so what we'll do is we're going to say docker compose. We're going to have logs, and we're going to follow logs. That's like tail-f. And what we're going to do is, so we want to watch our front end service, and we also want to watch our worker one. And so when we run this, and it's logs plural. And so as you can see, we get a full list of all the logs that we've had, and we're going to be able to use this so that we can follow and see what happens, because we write to this console. And you see it says it's front end, or it'll also say worker. Back into our browser, what we can do is we're going to hop into our dashboard. We see that we have our one server, and we don't have any jobs. What we're going to do is we're going to start our long-running task. And you can see our HTTP request was instant. And you can see that we've also logged from our front end. So I'm pausing this log. You can see that we have queued that our long-running task. And you can see worker one already picked that up almost instantly. And if I unpause, you can see it jumps down. And you can see that it took just slightly over 10 seconds for our worker to finish the job. And so if we hop back into our dashboard, you can see that we've had one succeeded job. This Hangfire dashboard is real time for the most part. And if we click into this, you can see how this job gets queued, that it's going to activate an instance of long-running job, which is our job class. It calls the perform method on this class with an instance of our job options, which it pulls from JSON that it's serialized. And this is important to know, that Hangfire is going to serialize your options, which in our case are an int of task time, into a JSON object. And so you want to keep these options as scalars as much as possible, or always. You never want to do anything that's not scalar. And so we can do this again. We can click this, click, and we should see that we have 7 jobs, 8 jobs being processed. And if we click into them, you can see that this one was created. It's been queued. It's now processing this job, which takes about 10 seconds. And if we refresh this page, you can see it succeeded. And Hangfire tells you how long it took between different stages for things to complete and finish. And so I think this covers everything that we're wanting to do with Hangfire. We didn't get to the scheduling repeat task, but we can definitely look at that next time. It's not that hard. What I'll do real quick is I'm going to pull in some unit test structures. So to kind of see how these tests work, what I've done is we're in the task controller, and you remember we have our task service and we call the long-running task method. So unit test on this is very simple. We create a mock instance of our task service. We pass that into our task controller, and then we call the action that we're wanting to test on that controller, and we just verify that our task service called that long-running task method once. And then because this is a controller action, we ensure that we call our redirect action result back to our home index controller action. And so the same principle of using these mocks apply to our task service. So here the task service takes in an instance of iJobRunner, and we call the queue long running job method with a task time of 10. And so in our test, we create a mock instance of the job runner. We pass that into our task service. And the way we test this is we create an instance of our options with a time of like 99. We're using the setup method on mock so that we're calling the queue method with everything, making sure it is a type of action. And then we override this callback so that we can invoke this, whatever callback happens inside of the service on our local instance of options. This bypasses, remember our job runner creates a new instance. It bypasses that instance that it creates here to use the one local to this test. And then we just assert the task time is equal to 10. And this is where you would say, like, if I called this on a user or a post or something of that nature, you would make sure that your scalar matches whatever your options are supposed to be. And then finally, in our job runner, because we're using the iBackground job client, we are queuing and using these methods. The way you test Hangfire is basically the same thing. We create our subject, which is our job runner, with a mock instance of the background job client. I created a local instant or local job to this test that follows our regular schema for this job framework. And then once we queue our job, we verify that our background job client is invoked with create. And we're just verifying that the argument for our job type is my test job. and that we have a single argument passed to that is my test options, and the value is set to whatever we set in this callback. And so that's everything needed to test this. And as you can see, we've actually created an end-to-end test suite here, all the way from our controller action all the way down into our task service from our business layer. And the only thing I didn't test is our job itself. And that's because the only thing we do here is, well, I guess I could have added a test to ensure that the task time sleeps for X amount of seconds, but that didn't seem too beneficial. So because this doesn't actually do anything, I didn't add a test or it's not anything I can test. So if you like this video, be sure to like and subscribe. Thank you for watching, and I'll see you next time.